Hi everyone, welcome to today's session. Myself Hima, Assistant Professor, Department of Information Technology, S.A.E. Engineering College. In today's session, I'll be talking about the basics of IP support protocols, which is a topic from the subject Computer Networks. Let's move on to the session. So IP or Internet Protocol is a basic building block of the Internet that enables the communication between devices across the networks. IP defines a set of rules that will address and route packets so that it can travel through the network and reach the correct destination. So along with IP, there are some more protocols has been developed to facilitate efficient and reliable data transmission. They are called IP support protocols. So they will work in conjunction with the IP. So these additional protocols will provide additional functionalities and services that enhance the overall performance, security and manageability of the IP networks. So here we will be discussing about mainly these three protocols. First one is Address Resolution Protocol or ARP. Second one is Internet Control Message Protocol or ICMP. Third one is Dynamic Host Configuration Protocol or DHCP. So all these three protocols will play an important role while maintaining the smooth operation of IP. So now let us see each of these protocols in detail. First one is ARP or Address Resolution Protocol. It is one of the important protocol in the TCP IP protocol stack. So as the name implies, the main responsibility of ARP is to map an IP address to corresponding MAC address. This MAC stands for Medium Access Control. It is also known as physical address or hardware address. So the main responsibility of ARP is to map the IP address into corresponding MAC address or physical address. So usually the network applications uses IP4 addresses, which is a 32-bit address, to communicate within the application layer. But when coming to data link layer, it deals with the MAC address, which is a 48-bit address. So the function of this ARP or the responsibility of ARP is to map this 32-bit IP address into the 48-bit MAC address. So these are some important terms associated with ARP cache, ARP cache timeout, ARP request and ARP response bar reply. So first one is ARP cache. So it is the place where this resolved MAC addresses will be stored. So whenever a MAC address is resolved, that device will store that MAC address into ARP cache so that it can be used for subsequent communication. Next one is ARP cache timeout. It indicates the time for which a MAC address in an ARP cache can reside. So after that it will get removed from the cache. Next one is ARP request. It is a packet which will be broadcasted along the network from the source to the destination to resolve the MAC address of the destination. So these are the contents of that ARP request packet. The physical address of the source, then the IP address of the source, then the physical address of the receiver, which will kept as empty because that has to be filled by the receiver, then the IP address of the receiver. So these are the contents of ARP request packet and this will be broadcasted along the network. Next one is ARP response bar reply. So this is actually a response which the receiver sent to the sender. So that will contain the MAC address of the receiver. So here the point to be noted is that this ARP request is a broadcast packet and ARP response is a unicast packet. So here this diagram will explain the working of ARP. So here we have a LAN and 5 computers are connected in this LAN. Assume that this machine wants to communicate with this machine. So this machine already knows the IP address of that machine, but it is not aware of the MAC address of that machine. So what it will do is, it will first look into its ARP cache whether the MAC address of that particular machine is available here. So if it is available there, it will read the MAC address from the IRP cache and will start communication with the device. But suppose if it is not there, then it will prepare an ARP request packet and it will broadcast the packet along the network. So the packet will be asking for the physical address of a node whose IP address is 141.23.56.23. So all the devices in the network will receive this packet because it is a broadcast. So while receiving the packet, these three devices will simply drop it because this is not the IP address of those devices. So once the device receives this packet, it will identify that this packet is internet for me. So it will prepare an ARP response message. And the MAC address will be stored in the ARP response message and it will be sent to the source device. So once the source device receives the ARP response, it will store the MAC address into its ARP cache so that it can be used for subsequent communication. So this is how the ARP will work. Now let us see some cases where the ARP can be used. First case is the sender is a host and wants to send a packet to another host on the same network. So both sender and the receiver are in the same network. So the sender can use ARP to find the physical address or MAC address of the host. Case 2 is the sender is a host and wants to send a packet to another host on another network. So sender is on one network and receiver is on another network. So definitely there will be intermediate routers. So the sender first looking to its routing table to get the routing information. After that it will find the IP address of next router. Then it will use ARP to find out the physical address of the router. Another case is the sender is a router and received a datagram destined for a host on another network. So here also there will be a router. So the router will check the routing table for the routing information. Then it can use ARP to find the physical address of the next router. Another case is the sender is a router that has received a datagram destined for a host in the same network. So here both the sender and receiver are in the same network. So the sender can use ARP to resolve the physical address of the host. Next is RARP, which stands for Reverse Address Resolution Protocol. It is a variant of ARP. So as the name implies, it does the reverse operation of ARP. It will find out the IP address when the physical address is known. So for that there is a server called the RARP server which will be in the same LAN. Now let's see the working of RARP. So this is a LAN in which 4 devices are connected, that is named as device A, B, C and D. So among this device C is the RARP server. So this particular device, it wants to know its IP address. It already know its physical address, it wants to know its IP address. So what it will do is, it will send an RARP request to network, that is a broadcast message. So every device in the network will be receiving the message. So these two devices, device B and D, will be discarding the packets because they are not the RARP server. So once the RARP server receives the message, it will reply with the IP address of the corresponding device. It will do a lookup into this RARP server table and it will send the IP address to the device A. This is how RARP works. So that's all about ARP and RARP. So next protocol is called Internet Control Message Protocol. So it is a network layer protocol that is used by hosts and routers to send IP datagram related issues back to the sender. So it is mainly concerned with sending and receiving messages. It uses ICMP echo test and reply messages for identifying whether a host is reachable or not. So here ICMP will handle both control and error message, but it will, the main function is to report error. It will not correct any error. Usually ICMP messages are embedded within IP datagram packets itself. So this is the IP header and the ICMP message will be embedded into this IP datagram, and this is a format of the ICMP message. The first field is a type which specifies the type of the message. Second field is called a code, that is the reason for this particular message, and the last field is the checksum which will cover the entire ICMP message. Now these are the types of messages that is handled by ICMP. Destination unreachable, source quench, time exceeded, parameter problems and redirection. First message, destination unreachable. So that means when the destination or the receiver is unreachable or it is not responding, then this message will be generated. So for example, if there is a sender machine A wants to send a message to B, then if B is not receiving the message, then the intermediate router will be intimating the sender by sending this destination unreachable message. It will tell that B is not reachable and B is not receiving the messages. Next message is called source quench message. It is mainly concerned with the congestion control. It is used when the sender is continuously sending packets to the receiver in a high speed rate, so that the receiver is not able to receive it properly. It is losing some messages, it is losing some packets. In that case, the receiver can send a source quench message to the sender saying or asking to reduce the sending speed. So after receiving this message, the source will reduce this message sending speed so that the receiver will be able to receive all the packets. And if the source and receiver are in different networks, then it can use a hop by hop source quench message so that every router will reduce the transmitting speed. So that is source quench message. Next is time exceeded message. It is same as time to leave. It will tell how much time a packet should leave. After that time it will get discarded. So there are the two ways when this time exceeded message can be generated. One is the packet discarded due to some wrong routing information. And second one is the destination device is not ready to receive any more packets. That time also the packet will get discarded and it will send a time exceeded message to the source. Next is parameter problem message. So when a router or host discovers any missing value in IP datagram, it will simply discard the packet and it will send a parameter problem message to the sender. For example, the checksum field in the message, ICMP message. So the received checksum should be equal to the calculated checksum, then only the receiver will accept that datagram. So if they are different, then the receiver will simply discard the message. So in that case, a parameter problem message will be sent back to the sender. Last message is called the redirection message. Redirect request data packets be sent on an alternate route. It is actually used when the routing table of the sender is very small. So only a very less number of entries are possible in the routing table. So with the available entries, it will be sending packets to the receiver. So when a router receives a packet from a sender, if it identifies that an alternate route is available, which is a better route, then it can send a redirection message to the sender saying that an alternate route is available, so that it can send in the new route. So for example, sender A wants to send to a router a message called R2. The name of the router is R2. Then according to the sender's table, there is a route to R1. So it will send the packet to R1. Upon receiving that, actually the packet is intended for R2. So upon receiving that, R1 identify this is a wrong route and an alternate direct route is available from A to R2. So it will send a redirection message to A so that A can send the packet directly to R2. So this is called redirection message. So that's all about ICMP. Next is Dynamic Host Configuration Protocol or DHCP. So it is mainly used to configure a host machine. It defines set of rules that will provide the IP address and other configuration information for a particular host. So if you see the word meanings, dynamic means automatically, host means any computer that is connected to the network, then configuration means to configure a host that is with the IP address or subnet mask or gateway address, whatever it is. Then the protocol defines set of rules. So combinedly we can say that the main role of DHCP is to dynamically configure the host in a network. So these are the main components of DHCP. DHCP server, DHCP client, IP address pool, subnet, lease, DHCP relay agent. First one, DHCP server. DHCP server is a networked device which will hold the IP addresses and the corresponding configuration information. DHCP client is any machine that will receive the configuration information from the server. So it can be a desktop or laptop or an IoT endpoint device or any other device which is connected to the network. Next one is the IP address pool, which stores the range of IP address that are available for the client. Next one is the subnet. It is a partitioned segment of the network. It is actually done to manage the network easily. Then lease is the time for which a client can use an IP address. So once the lease time expires, it has to renew it. Next one is DHCP relay. DHCP relay is an agent that can be used when the server and client are on different networks. So what happens is the DHCP relay agent will be responsible for forwarding this request and response between the DHCP client and DHCP server when they are on different network. Now, how the process happens? When you go to online, when your computer connects to internet, first your computer will be requesting an IP address for communicating with other devices to the DHCP server. That is called DHCP discover message. Then in response to that, the DHCP server will allocate a particular IP address and other configuration information, and it will send a DHCP offer message to the requested DHCP client. Then next step is, upon receiving this offer message, the client machine, that is your computer, it will accept the IP address configuration by sending a DHCP request message to the server. So once this happens, your computer can communicate with the other devices in the network. Next, we will see the different stages in DHCP client-server communication. So there are mainly 4 stages. First stage is called discovery stage, second stage is called offer stage, third stage is called request stage, and fourth stage is the acknowledgement stage. In discovery stage, the client will broadcast a DHCP discover message to discover the server on the network. The next stage is called the offer stage, where the server will respond with an IP configuration to the client. Then next stage is called the request stage, where the client will accept the IP configuration and it will show the acceptance through this request message. The last stage is called acknowledgement stage, which will be sending the server will be sending an acknowledgement back to the client. So these are the different stages of DHCP client server communication. So next we will see each of these messages in detail. The first message is DHCP discover message. This is a message which has been sent by the client machine to the network that will be broadcasted to discover the DHCP server. So every device in the network will be receiving this message. Upon receiving this message, the server will reply with an offer message which will contain the IP address and other configuration information for the client machine. Then once the client receives the IP offer message, it will check whether there any other device in the network is using the same IP configuration. If it doesn't receive any reply from other devices, it will send a DHCP request message to the server, which shows the acceptance of the IP address and other configuration from the server. The next message is the DHCP acknowledgement message that has been sent by the server machine to the client, and it will update the IP address configuration and other information about the client in its database. So that with that the communication will get over, and the client can use the IP configuration for further communication. And there is one more type of message called DHCP, negative acknowledgement message. This is sent when the server wants to say no to a client. That is, it does not want to send any configuration information to a client. For example, if the IP pool is empty, or if the server is receiving an invalid request, in those cases it will be sending a negative acknowledgement to the client. So it's simply saying no to the client. So that's all about the basics of these IP support protocols, ARP, ICMP and DHCP. Now we will discuss some questions. First question, the address resolution protocol or ARP is used for. We know what is ARP. ARP is used for finding the MAC address corresponding to an IP address. So here option D is correct, finding the MAC address that corresponds to an IP address. Next question, what does DHCP stand for? Option A, dynamic host configuration protocol. Option B, dynamic host configuration provider, digital host communication provider, digital host communication protocol. So the answer is option A, dynamic host configuration protocol. Next question, which protocol is used by ping command? TCP, UDP, ARP and ICMP. So ping command, basically it is used to detect whether a machine in the network is active or not, it is responding or not. So here TCP and UDP are transport layer protocols, and ARP is the address resolution protocol. So option D is the correct answer, ICMP. So ICMP, echo, test and reply packets can be used to implement ping command. Next question, which of the following describe the DHCP discover message? It uses this address as a layer 2 broadcast. It uses UDP as the transport layer protocol. It uses TCP as the transport layer protocol. It does not use a layer 2 destination address. The options given are 1 only, 1 and 2, 3 and 4, 4 only. So we have to check which all statements are correct in the given statements. So first statement, it uses this address as a layer 2 broadcast. It is correct only, it is a layer 2 broadcast message. Then statement number 2, it uses UDP as a transport layer protocol. So here DHCP is a connectionless protocol, so it will be using UDP as the transport layer protocol. Then option 3 is not correct. It is mentioning as it uses TCP as a transport layer protocol. It is not correct. And fourth one, it does not use a layer 2 destination address. That is also wrong. It will be using all the addresses because it's a broadcast message. So option B is the correct answer. That is 1 and 2 are correct statements. Next question, you want to implement a mechanism that automates an IP configuration including IP address, subnet mask, default gateway and DNS information. Which protocol will you use to accomplish this? So here basically what we want is we need to configure an machine. So of course we will be using DHCP, that is used for dynamic configuration of machines. So here the options given are SMTP, SNMP, DHCP and ARP. So the correct answer is option C, DHCP. Next question, this is one of 2 protocols that let a network administrator supervise and distribute IP addresses from a central point. It automatically sends a new IP address when a computer is plugged into a different place in the network. So what is asked is, when a computer is placed in a different place in a network, which protocol will be using? So definitely we have to use DHCP to configure the new computer in that place. So the option is D. DHCP is the correct answer. Next question, consider the following 2 statements. Destination MAC address of an ARP reply is a broadcast address. Destination MAC address of an ARP request is a broadcast address. So which one is correct choice? So considering statement 1, Actually, ARP reply is a broadcast address. It is not correct. ARP reply is a unicast message, and statement 2 is correct. ARP request is a broadcast address. So the answer is option C, that is S1 is false and S2 is true. Last question, which one of the following protocols is not used to resolve one form of address to another one? The options given are DNS, ARP, DHCP and RARP. Here DNS stands for domain name system, which maps a domain name into corresponding IP address, and ARP is address resolution protocol, which maps from IP address to MAC address, and RARP, which maps from MAC address to IP address. So all those three are address translation protocols, but DHCP is a IP configuration protocol. So option C is the correct answer, DHCP. That's it. So far we have seen the basics of IP support protocols, ARP, DHCP and ICMP, and we have solved some questions also. That's all for today. See you on next video. Thank you.